All right, guys, this is a review for the Unit 9 test, analytical geometry. Um, yeah, we can go ahead and work this. I'm kind of tight on time, so I'm going to try to kind of speed through these so I can try to get this done and get this out to you as soon as I can. So if there's any mistakes you catch, just ask me about it. It's likely I'll make it. It's like 5:30 in the morning, so I'm still trying to wake up. Haven't even had my coffee yet. So yeah, let me know if you see any mistakes or I missed a sign or something. Just let me know. It's a good chance I might make a mistake if something just doesn't look right. All right, so let's get started with the first section. We are doing the trig identity. So what I would need is my um, trig identities formula sheet from my notes. I'm gonna grab that if I can find it. So I'll get this, this sheet so I can have these identities handy, and then I can go from there. All right, so the ones that don't have equal signs, you're just trying to get it simplified. You don't want any fractions, and you want to write it in terms of like uh, one term if you can. Um, so we do want to do away with that. Same thing here. We want to try to get rid of this fraction and write it into maybe one term if we can, probably two at most. So let's get into this first one. We got, make sure I got the right review. All right, so we got sine x, secant, secant x, cotangent x. And we want to try to simplify this as best we can. Sometimes I like to try to maybe get a plan and think about where I'm going so I can maybe figure out where I'm going to end up. So I'm thinking if I can change secant using the reciprocal identity, I can maybe change it to cosine, and then I'll have sine over cosine, which will be tangent. And then I think tangent and tangent can work together. Maybe something would cancel out. So let me try to go that route. And I might start this and say, you know what? That's not going to work. Maybe let me try something else. So let me do that. So I'm not going to change sine just yet. I will change secant to its reciprocal, which is 1 over cosine x. And then I'll also change cotangent, just so I can kind of see what happens. So usually looking at the quotient identities, cotangent is cosine over sine. So I would do cosine x over sine of x. And now that everything's laid out, I think I see what's going to happen. So all of these terms are being multiplied on top and divided on the bottom. Excuse me. So here I've got cosine divided by cosine, those cancel, and I also got sine divided by sine. So all I'm left with is just 1. Second one. Number 2, we got tangent of x divided by sine x secant squared x. All right, so let's see here. Maybe I'm thinking I could change secant to cosine, and then that'll give me tangent because I have sine divided by cosine, which will give me tangent, and then maybe I can cancel tangents out, and then I'll see what I got from there. So let me maybe try to go that route. So I'm not going to change tangent just yet. I'm not going to change the sine x just yet, but I will use the reciprocal identity and change secant to its reciprocal which is 1 over cosine. Since it's squared, I'll square them both. All right? And then if I give one of these cosines and put them under here, so in other words, since this is cosine squared, it's really cosine times cosine. I could take one of those cosines and put them under sine, and that would give me tangent. So let me write that. I guess I should write it out. So I have divided by tangent. I'll have sine x over one of the cosines times 1 over the other cosine of x. So if I multiply these on the bottom again, I get back to x squared. I wrote it like this because the quotient identity tells me that sine over cosine is tangent. So then I can do tangent, and then I think I can cross the tangents out. So let me just show that. So we got tangent x over tangent x times 1 over cosine x. So the tangents cancel because this is all multiplication. Then I'm left with 1 over cosine x. So what I could do is keep change flip. I would flip the bottom and it would be 1 times cosine x. I can do that. I'll follow the identities and go that route. So I get 1 over cosine. Cosine's reciprocal is secant. So if I have, where's it at? 1 over cosine, I can write that as just secant. So secant x. And then I'll do secant's reciprocal, which gives me cosine x. All right, number 3. Number 3, we got secant x over tangent x minus tangent x over secant x. And this equals cosine x cotangent x. So now this one I'm actually verifying. I want to prove that either the left or the right side equals the other side. I think this time we start on the left side and we want to show how can this left side be transformed to look like this right side. So I want to somehow get this to simplify, change, be reduced, multiply. I want to get this side to look like this side. What jumps out at me is I have 2 terms and a minus sign over here on the left, and I don't have that over here on the right. I've just got a cosine and a sine being multiplied together. So right off the bat, I'm thinking I need to make this into one fraction, and then I'll only have like one set of terms, and then I'll be able to maybe simplify and see what happens from there. So I think to do that, we need a common denominator to be able to turn this left side into one fraction. So this side would need secant times tangent on the bottom. This side I would multiply by tangent, and it would give this side a denominator of secant times tangent. So I guess I'll write out what I mean. If I'm starting off with secant x over tangent x minus tangent x over secant x. All right, and just for clarity, you can't cancel these two out because they're separated by subtraction, not addition. So you would be subtracting these two, which means you will put the denominators together. You can't cancel out because it's not multiplication. So I will multiply this side by secant, this denominator, and I'll multiply this side by tangent, this denominator. All right, and now both denominators have secant tangent as their common denominator, so I'll be able to put them together. So let's multiply what we got on top. I get secant times secant, which is secant squared, minus tangent times tangent, tangent squared. And then on the bottom, they both have the same denominator, so I'm gonna put them together. Each denominator is secant times tangent. So I'm gonna just write it as one together function. Secant x times tangent x. All right, and I can't cancel any of this out because these are two separate terms separated by subtraction, and then I'm multiplying these two. I would need to be multiplying across the top in order to just cross out and simplify, so I can't go that route. But I do see these terms are now squared, and whenever I see some terms being squared, I think about Pythagorean identities because that's where the terms are squared. So if I go and look for a set of terms that has a secant squared in it, I come to this one, and I see that 1 plus tangent squared equals secant squared theta. Now, this formula does not look like that. Well, this does not look like what I have, but what I can do is maybe change this formula around to where I get secant minus tangent, both of those terms squared. And if I look here, secant, I can do minus tangent if I subtract tangent from both sides. Let me show you what I mean. I got 1 plus tangent squared x equals secant squared x. If I subtract tangent from each side, I get 1 equals secant squared x minus tangent squared x. So I can substitute in for this to equal 1. So that's what I'm going to do right here. This top is going to come out to equal 1. So I get 1 divided by secant x tangent x. And I'll separate these so we can just clearly see what we're about to do. I got 1 over secant x times 1 over tangent x. And then I think to get my answer, I'll do secant's reciprocal, which is cosine, and then tangent's reciprocal, which is cotangent, to get my final answer. Got my x. All right, and that's that problem. All right, one more of these. We got number 4. We got cosine of x over tangent x plus secant x equals 1 minus sine x. All right, so if I'm looking at this one, I'm thinking, I don't see any ones or any signs here. So that is kind of a challenge to get me started. And I probably don't want to start doing reciprocals here. I mean quotient identities or reciprocals, because I don't want to put fractions here when I don't need them. I'm thinking what we just used maybe could get the denominator to change to be 1 maybe, because I got a tan and a secant. I'm thinking if I multiply by tangent by the conjugate, which is tangent x minus secant x, I'll get tangent squared minus secant squared, and then I'll be able to use Pythagorean's identity to somehow get this bottom to be just a 1. And then I can try to sort out what's on top. So I think maybe I try that to get started. And we'll see where it takes me. It might not take me anywhere, but we'll see if that takes me somewhere. So I'm thinking I'll rewrite what we got on the bottom. And I'll multiply the top and the bottom by the conjugate. And so the conjugate is the same terms that are on the bottom, but you just change the middle sign so that the middle terms cancel out. So here on the bottom, well, on the top, I could do the top. On top, you have tangent times cosine. That's that. Then you'd have secant times cosine, so minus secant x cosine x, all divided by first times first. First times first gives you, and I should write it like this. First times first gives you tangent squared. And then the middle terms will cancel, so I don't have to worry about those because the sign's different. I'll just do last times last, which is minus secant squared x. And this is like what we just did here, where secant squared x minus tangent squared x equals 1. And, oh, actually, I got it backwards, don't I? So let's see, what would this equal? If I go back to here, I think if I subtract secant and bring it over here, that would give me, and I'm starting off from this Pythagorean identity. So if I subtract secant and put it over here so it would look like that, I would get 1 plus tangent squared x minus secant squared x equals 0. And then obviously I just want this, so I'll subtract 1 from each side, and I see that tangent squared x minus secant squared x equals -1. So I think this can come out to equal -1. So I will show that in the next line. Tangent x cosine x minus secant x cosine x, all divided by -1. And maybe let's wait till the end to deal with this -1. So I don't have any fractions on the top yet, but if I do quotient identity, I'll get maybe sine over a cosine, and then I can combine those two, and then I think these two will probably cancel out because they're reciprocals of one another. So let me change, and then let me come down here so I got as much space as I can try to get. Let me write tangent as its quotient identity, which is sine x, I was about to write theta, over cosine x times cosine x. So let's do this. Sine x, cosine x is what tangent was, but I used the quotient identity to write it like so. Cosine x is what I already had, then minus, if I do the reciprocal identity for secant, I get 1 over secant, 1 over cosine. Let's see if I have a, so it should be 1 over cosine, because that's secant's reciprocal times cosine of x. All right. Cosines cancel, which will leave me with just sine, and here the cosines cancel as well. And I almost forgot, this is all over -1. So what I'm left with here is just sine. Here I got -1, all over -1. So this -1 is just going to change the signs of what I have here. It will make it negative sine x plus 1. And then if I change the order, just 1 minus sine x, I can make it look like what we wanted to verify. So that's that. All right, so those are our identities. Like I say, y'all, there's different paths to get to your destination. So you might do something slightly different, but if we come out to get the same simplified form, or maybe if you can simplify a little bit more to get it into the form that we got it in, or that I got it in, you're good to go. So just because you didn't do what I did, or you did it in a different order or something, it doesn't make it wrong. It's just different. There's a lot of different paths you can take to get to this destination. So let me know if you have any questions on this. All right, go to the next section and we start doing sum and difference formula. So we got these 3 different sum and difference formulas depending on what we want to find. All right, so in each of these starting out cases, we want to try to figure out which 2 angles we can either add together or subtract to give us the angle that we're trying to find. So in this first one, we want to try to find sine of, this is the second number one. Sorry for my numbering. Sine of -7 pi over 12. So if you look somewhere in your notes, you should have all of these already kind of converted for you. So let's see, I'll convert some of these first ones real quick. This would be 2 pi over 12, 3 pi over 12, 4 pi over 12. And I don't think any of these are big enough to get me -7. This would be 6 pi over 12. Over here, if I multiply the top and the bottom by 4, I would get 8 pi over 12. If I multiply by 3, 9 pi over 12. And since I'm this far, let me keep going. 10 pi over 12. And here would be 12 pi over 12. So to get -7, I think I can use 9 pi and 2 pi over 12. 2 minus 9 will give me that -7. So those are the 2 angles I'm going to use. So I'll do sine of 2 pi over 12 minus 9 pi over 12. Sorry you couldn't see that. So now this is how I get -7 pi over 12. And right now, I don't know what these exact values are, so I'm gonna go ahead and reduce them back to what I was starting with. So this is really sine of, this one was pi over 6 minus, this one was 3 pi over 4, I believe. So these are the 2 angles I'm using. I'll go to the subtraction formula for sine, which is right here, and I'm going to do sine of A times cosine of B minus cosine A sine B. So I'll write it out. I got sine of the first angle times cosine of the second minus cosine of the first angle sine of the second angle. Since I know my unit circles, I'll go ahead and write these exact values. Sine of pi over 6 is 1/2. Cosine 3 pi over 4, since it's a 45, I know it's root 2 over 2. 3 over 4 is in the second quadrant, so cosine should be negative. Minus cosine of pi over 6. If sine of pi over 6 was 1 over 2, then cosine will be root 3 over 2. And then sine of 3 pi over 4, since it's a 45, it's root 2 over 2. And in the second quadrant, sine is positive, so I leave that as positive. I multiply across the top, I got 1 times negative root 2, which is negative root 2 divided by 4. The other side will also be divided by 4. So I would do minus root 3 times root 2, which is root 6. And this should be my answer. Sorry, I gotta clock in. Number 2. Sine of 19 pi over 12. So I need 2 angles to get me 19. If I go here, based on what I got, I think 10 over 12 and 9 over 12 will give me 19. Now, you could go to these angles and you can use these angles 100%. I think these 2 will work, so I'm going to use these 2. Like I say, you might use 2 different ones. So I will do sine of 9 pi over 12 plus 10 pi over 12. I don't really know what that is just from looking at those ones, so I'll reduce them back to their original forms, which is 3 pi over 4 plus 5 pi over 6. So the formula is going to be similar to the last one, except I'm going to add here. So I'll do the sum formula for sine, which is similar to the subtraction one, except the middle sign changes here. So what I get is, and I'll write what I'm going to do, sine of 3 pi over 4, cosine of 5 pi over 6, plus cosine 3 pi over 4, sine 5 pi over 6. Root 2 over 2 times negative 3 over 2 plus negative 2 over 2 times 1/2. So these are just using my unit circle to get the exact values. 2 times negative root 3 gives me negative root 6 over 4. It's plus, but this negative sign will make it negative. So negative 2 times 1 is minus root 2 over 4. So this should be my answer. All right. Let's go on to number 3, I think. Number 7. Nope, because I didn't read number. So jumping to number 7. Right here, cosine of 7 pi over 12. Cosine 7 pi over 12. So 2 angles, maybe 4 and 3. 4 pi over 12 plus 3 pi over 12. And I'll write them in their original form, which is cosine of pi over 3 plus pi over 4. So I'll use the addition formula for cosine. Cosine A, B, cosine B minus sine A sine B. So cosine of A is 1/2 cosine of pi over 4 is a 45, so that would be root 2 over 2. Formula tells me to subtract, so I will. Sine of pi over 3 is positive 3 over 2. Sine of the 45 is 2 over 2. 1 times root 2 is root 2. Negative root 3 times 2 is minus root 6, all divided by 4. All right, number 7. Sorry, number 8. Cosine negative 5 pi over 12. Two angles to give me negative 5 pi over 12. Sorry, 7, yeah, 5 pi. So I think 8 minus 3 is 5. Let's see if there are any others we can do to get 5. Maybe 9 minus 4, 4 minus 9 gives you 5. 8, 10, 9. You probably could go down to this quadrant and find some. I think we're going to go with, let's do 3 minus 8 to give me minus 5, negative 5. So we'll do cosine of 3 pi over 12 minus 8 pi over 12. So how we get negative 5. The 8 needs to be the one subtracting to give me a negative number. And this is really pi over 4 minus 2 pi. Not 3 pi, 2 pi. 2 pi over 3. Right, so we're doing the subtraction formula for cosine, the difference formula. So cosine A, cosine B plus sine A, sine B. So we add in between this time. So cosine of A is 2 over 2. Cosine of negative 2 pi over 3, that's a 60, so cosine should be negative 1/2 plus sine of pi over 4, and then sine of 2 over 3 should be root 3 over 2, and it should be positive. This comes out to equal negative root 2 plus root 6 over 4. All right. Number 13. We got tangent of 255. All right, so 255 isn't on my unit circle. I need two angles that I can add or subtract to give me 255. So what I might do is say, let's see, what if we did, let's try maybe 225 plus 30, what's that? 255. So one combination is 225 plus 30 gets me that 255. You can do other combinations. Let's see if we can find another one just for kicks. Maybe I could do, let's say I did 120, or actually let me do 255 minus 120, see if that's anything. 135. So I could do 135 and 120. I could add those together to give me 225. I think I'll do 225 plus 30. There's probably a lot of other combinations. So even if you pick some other ones, we should still end up getting the same exact value once we finish. So I'll do tangent of 225 plus 30. So this time I'm doing the sum formula for tangent. So tangent of the first angle plus the second angle. So I'll go tangent of the first plus tangent of the second. All right, so maybe I'll go over here and do a little bit of back work. So let's see. Tangent of 225. 225 is a 45-degree angle. So tangent of 225, if it's a 45, I know tangent is y over x. Tangent would be negative root 2 for the y over negative root 2 for the x. Since those are the exact same thing, this will come out to be positive 1. And let's say tangent of 30, that's y over x. At 30, the y coordinate is 1/2. The x coordinate is 3 over 2. I would keep 1/2, and then I would multiply by the bottom's reciprocal. 2 would cancel, and I get 1 over root 3, which would be rationalized to be root 3 over 3. All right, so these are my two exact values for those two angles. And so I'll substitute them into this formula. Tangent of A plus B. The first angle is 225, so it would be 1 plus tangent of 30, which we said was root 3 over 3. Divided by, excuse me, 1 minus tangent A, which is just 1, times B, which is root 3 over 3. This is my answer. I just need to simplify it. So 1 times this will be just this. I do want to get to have just one fraction on the top and one on the bottom. So what I'll do is convert 1 to be 3 over 3, and then they'll have the same denominator that I can use to add them. So what I mean is do 3 over 3, which is 1, plus root 3 over 3, which is what I already had, and that's my fraction on the top, divided by this one I'll change to 3 over 3 also, and then this is minus root 3 over 3. So what I did is just combine them. I wrote the ones to be 3 over 3, and I already had root 3 over 3. So they're both over 3, so I just put them together. All right, and at this point, I got to keep chain flip. So I'll keep the top piece. I'll multiply by the reciprocal of the bottom. So 3 divided by 3 minus root 3. The 3's cancel, and what I get is 3 plus root 3 over 3 minus root 3. Now for this test, I'm okay with you leaving it like that. I should, I guess, go ahead and rationalize it just so we can see how we rationalize it. If you did rationalize it, you'd multiply by the conjugate of the bottom, and the conjugate would be 3 plus root 3. So let's do that and see what we get. If I multiply the top and the bottom by 3 plus root 3, I would get 3 times 3, which is 9, 3 times root 3 plus root 3, 3, root 3 times 3, and then last times last is root 3 times root 3, which is just 3. All divided by, the middle terms will cancel on the bottom, so 3 times 3 is 9, minus root 3 times root 3, which is 3. I will combine my like terms. 9 and 3 is 12. I have a total of 6 root 3's all over 6. And then all 3 of these terms have a multiple of 6. These two cancel out. These two can be reduced to 2 and 1. So what I'd end up with is 2 plus root 3. All right, one more sum and difference to go. We got tangent of negative pi over 12. This is number, because my numbering's all over the place, 14. Tangent of negative pi over 12. So for this one, I think we can just do, we're going to do any of these first quadrant ones. Maybe we'll do 3 minus 4, which will give me negative 1. So we'll do tangent of 3 pi over 12 minus 4 pi over 12. Then I'll reduce these to what they really are, which will be tangent of pi over 4 minus pi over 3. So we're doing the difference formula for tangent. So I'll do tangent of A minus tangent of B. And last time we did tangent of a 30, and we got root 3 over 3. If we do tangent of a 60, let's see, I'll come over here on the side and do it. Tangent of a 60, tangent of 60 y over x. Y at the 60-degree angles is 3 over 2. X is 1/2. So I would keep multiply by 2 over 1. These cancel, and then I'm left with just root 3. So tangent of the 60s is root 3. So I got tangent of A. Tangent of 45 is 1. We found that earlier. And then the first quadrant tangent is positive, so positive 1. And then the formula tells me to do minus tangent of B. So tangent of pi over 3, we just found that that's root 3 divided by 1 plus tangent A times tangent B. All right, on the top I got 1 minus root 3 divided by 1 plus root 3. That's my answer. I need to rationalize it, so I'll multiply by the conjugate of the denominator, which is 1 minus, sorry, gotta change the sign. So 1 minus root 3. All right, so then I'll FOIL this. 1 times 1 is 1. Outer times outer. 1 times negative root 3 is negative root 3. Inner times inner, also negative root 3. Last times last. Negative times negative makes it positive. Root 3 times root 3 is root 9, which is just 3. All divided by 1 times 1. The middle terms cancel since the sign's different, so I just need to do last times last. Negative root 3 times root 3 is 3. I have 2 negative root 3's, and then I also have 1 plus 3. So 4 minus 2 root 3 over negative 2. All of these terms have a 2 in common, so I'll divide everything by negative 2, and that'll get rid of this fraction completely. So 4 divided by negative 2 is negative 2. Negative 2 divided by negative 2 is positive 1. So negative 2 plus root 3. All right, that's sum and difference. right, let's go to the next section. We're going to start doing double angle formulas. So number 19, we want to find the double angles. Use double angle formulas to find the exact values. And we start off with this situation. We got sine of theta equals 12 over 13, and then it tells us that this angle is in the second quadrant. So for double angle, we're using these formulas. And in this case, I'm just given a situation. So I want to make sense of this situation. I'll use the trig ratios that I get from this situation to substitute into the formulas here. So let me deal with this right here. I'm gonna draw an angle in the second quadrant, and I'm gonna use what I know about sine to do this angle. So to get me started, this is number 19. We got sine of theta equals 12 over 13 in quadrant 2. So I'll draw this angle in quadrant 2. Somewhere here, I don't know where this angle is. I know it's some angle in quadrant 2. And I know that sine's ratio is opposite over hypotenuse. So I will turn this angle into a right triangle by going to the x-axis. My reference angle theta is here. And then I know the opposite side is 12, and I know the hypotenuse is 13. All right, so when I start using these formulas, I'm going to need a cosines ratio here, here, and then I'll need tangents ratio. So let me go ahead and find those two ratios. I need to find this missing side. Now, you probably recognize this as I think a 5, 12, 13, but let's say you didn't. I could use Pythagorean's theorem to find the missing side right here that I need. So a squared plus b squared equals c squared, where c squared is always the hypotenuse. I get 12 squared plus b squared equals 13 squared. 12 squared is 144 plus b squared equals 13 squared, 169. I subtract 144 from both sides and I get 25. And then I take the square root of 25 and I get 5 as my adjacent side. And now, since I go to the left, this will be -5. So I found the missing side of the triangle. Hello?
Oh, I didn't want to interrupt you if you were.
That's okay. I'll delete it. I'll edit the video later.
Okay, Samuel hasn't finished.
Okay.
Okay?
All right.
And I have breakfast duty still.
Okay. So he's supposed to leave it with me when he leaves?
Yes, please.
All
Can
right.
you leave it with Mr. Shields when you're finished? Okay,
All
thank you. Bye.
All right. So, and I make it -5 because I'm going left 5. So, I got my three sides. Let me write my ratios. So, we already know what sine is. 12 over 13. Cosine will be a over h. The adjacent side is -5 over the hypotenuse, 13. And then tangents ratio, based on this situation, will be TOA, O over A. Opposite side is 12 over A, which is -5. So I got all my ratios I need to do the formula. Let's do it. So I'll say this is A, sine's double angle. I'm just following the formula. It'll be 2 times the exact value for sine times cosine. 2 times sine. Sine was 12 over 13 times cosine, which was -5 over 13. I multiply across the top, and at this point, I can't reduce anything, so I'll get the most simplest fractions I can get. So across the top, I'll just do 2 times 12 times -5, and I get -120 over 13 times 13, which is 169. Cosine, like you have 3 different formulas you can use. I just wrote the one that I use, and I think most of you guys used. I'm going to square cosine, and then I'll subtract sine squared. So cosine double angle equals cosine squared. So -5 over 13 squared minus sine squared, which was 12 over 13. All right, so when I'm squaring this fraction, I square the top and I square the bottom. So I get 25 over 169 minus 144 over 169. Since they got the same denominator, I can subtract to the top numerator. So I'll do 25 minus 144, and I get negative 119.
Is this for math too?
It is. Yep, have a seat. I just got one more problem. I'm recording for a video, then I'll come help you out. So last one, C, tangents double angle. So like I said, if you wanted to, you could do tangent of theta is sine over cosine. So since we have sine and cosine, you could do sine divided by cosine. You keep change flip, and I think you get 120 over 119, and that would be it. I'll go ahead and use the formula just so we make sure we know how to use the formula. So tangent is half angle. I've got 2 times tangent over 1 minus tangent squared. So let's do that. I got 2 tangent, we said was 12 over 13 divided by 1 minus, where's the formula there? 12, I'm sorry, not 12 over 13. It should be 12 over -5, right? 12 over -5. And this one too. All right, so I can multiply these two together to give me, I say negative 24 over 5 divided by, let's do this right side first, and then we can convert 1 to have the same denominator. So 12 squared is 144 over -5 squared, which is 25. And then I'll subtract this from 1. So the 1 I'll write as 25. Over 25. So I'll put these together. -25 minus 144, I think 119. Negative 119 over 25. So at this point, I just need to keep change flip. I'll keep the top. So negative 24 over 5. I'll multiply by the reciprocal, so I'll flip the bottom. I got 25, 119. All right, I can reduce these two. 25 can be divided by 5 times, so that goes to 1. I got negative 24 times 5 was negative 120. And then 1 times negative 19 is negative 119, which is just 120 over 119, which, if you rewind, is what I believe we said we would get for this one. All right, so we got about 5 problems left. I'll do these a little bit later, since we got students coming in. Be sure to check it out if you want to see these last couple problems work.